Hello, Algebra 2 students. This is the review for our quiz 6.2, our second quiz of Unit 6, and this is for my regular Algebra 2 students. Here we go. First question, find the inverse of the function. The way this is going to work is I'm going to put this up here. You're going to hit pause, try the problem. I'm going to show you the answer. If you got it, marvelous. Fast forward to the next question, or you can listen through the explanation to figure out how we got the answer that I show. Okay? So hit pause at this point, try the problem. Okay, the answer you should have gotten was y equals negative 1/6 x minus 4/3. If you got that, great. Continue on to the next question. If not, here's the explanation. First of all, I would change the f of x to be a y. So it's y equals negative 6x minus 8. Now we're doing the inverse of the function. Whenever we're doing the inverse of the function, we're going to switch the x and the y. So it becomes x equals negative 6y minus 8. And now we're going to solve this equation for y. We're going to add 8 to both sides. Get x plus 8 equals negative 6y. And then divide everything by negative 6. So you're left with an answer of y equals negative 1/6 x. And then we're going to simplify this fraction and make it negative 4/3. Now that is a perfectly acceptable answer. This is the one I would prefer. But you could also have the following as an answer. You could have left it as one big fraction and had x plus 8 all over negative 6 equals y. And that would be perfectly fine as well. Okay, next problem. Same type of problem. Find the inverse of this function. F of x equals 5x to the 7th plus 4. So pause, try the problem. Here is your answer, the 7th root of x minus 4 over 5. So if you got that, continue on to the next problem. If you did not, here we go. Switching the f of x to be a y. So y equals 5x to the 7th plus 4. We're doing the inverse, so we're going to switch the x and the y. So we get x equals 5y to the 7th plus 4. Now we need to solve for y, so we're going to subtract 4 to both sides. X minus 4 equals 5y to the 7th. We're going to divide both sides by 5. Then we are left with y to the 7th equals, and again you can write this as one big fraction or two separate fractions. It does not matter. I am going to keep it as one big fraction in this case. So we have x minus 4 all over 5 equals y to the 7th. This is being done to the 7th power, so how do we undo that? We 7th root it. So we're going to 7th root both sides. So we're going to end up with the 7th root of x minus 4 all over 5 equals y. We are not going to rationalize the denominator in this case. This is our answer. You could, however, have separated that fraction and had the following as your answer. The 7th root of 1/5 x minus 4/5 equals y. And that is a perfectly acceptable peachy answer as well. Okay? Next problem. Verify using functional composition that the two functions are inverses of each other. So what we're asking you to do in this case are the functional compositions. So f of g of x, and then we want to find g of f of x. Now remember, when you're doing the functional compositions, that we need to make sure that we simplify these, and when we simplify them, we want to end up with just plain old x at the end. As long as that's the case in both of our compositions, then it proves that our two original functions are inverses of one another. So for this first one, we're going to take the f equation and we're going to plug in the g equation into the x. So we're going to have 3/8 times 8/3 x minus 16/3 and then plus 2. We're going to distribute out the 3/8. 3/8 times 8/3 x gives us just x. 3/8 times negative 16/3 is going to give us negative 2, and then we have the plus 2. Negative 2 plus 2 cancels out, and we are just left with x, which is exactly what we want to be left with, so yay! Now we're going to do the same thing, but we're going to reverse the process. This time we're going to be given our g equation, and we're going to plug in the f function into that. So 3/8 x plus 2, and then minus 16/3. We distribute out 8/3 times 3/8 x gives us just 1x, and then 8/3 times 2 gives us 16/3, and then minus 16/3. 16/3 minus 16/3 cancels out, and we are just left with x. So yay, we're left with x in both cases, so that means our two original functions are inverses of one another. Okay, next problem is a graphing problem. We want to graph the function, and then we want to state the domain and the range. The first thing we need to do is find our Hankin-Kelly point. So in this one, our Hankin-Kelly point is the point 0, 0. So we're going to do an XY chart. 0, 0 is our starting point. Whatever our Hankin-Kelly point is our starting point for a square root. Then we're going to do 1, 2. We're going to skip 3 and go to 4. So you can put these in manually into our equation, or you can plug them in the calculator and use the table function. Remember to do this. You hit y equals, type in your equation, then you do second graph, and that gives you your table function. So we plug in 1, we get out negative 2. We plug in 2, and you get negative 2.8. And you plug in 4, and we get negative 4. So we're going to graph these on our graph. The point 0, 0, 1, negative 2, 2, negative 2.8, 4, negative 4. Then we draw our graph. Okay, we want to state our domain and our range here. Our domain has to do with our x values. Our x values start at 0, and they become greater than or equal to 0 as we move to the right. We keep plugging those numbers in, and it works out. Our range, again, we start at 0. We get those from our Hankin-Kelly point, but this time, instead of going up and picking the numbers that are greater than 0, those don't work. So we want the ones that are less than 0. So it's going to be less than or equal to 0 in this case. Okay, next function is y equals the square root of x minus 3. We start off by finding our Hankin-Kelly point. Hankin-Kelly point is 3, 0, because remember, Hank lies, Kelly tells the truth. There is no Kelly, so that means it's 0. We're going to do an XY chart. We start off with the Hankin-Kelly point, 3, 0, 4, 5, and then 7. I skipped 6 because 6 is just going to give me a decimal, and I don't want to deal with a decimal. 7 I know is going to give me a nice number, so I want to use a 7 there. So we plug in these numbers. Again, you can use the table function on your calculator or do these by hand. 4 minus 3 is 1. The square root of 1 is 1. Plugging 5 in, 5 minus 3 is 2. The square root of 2 is 1.4. And plugging in 7, 7 minus 3 is 4, and the square root of 4 is 2. So we're going to plug in these points. 3, 0, 4, 1, 5, 1.4, and then 7, 2. And here's our graph. Our domain, we start off at 3, and we're plugging in the numbers that are bigger than or equal to 3. In range, we're starting at 0 because that's our Kelly point, and this time we're plugging in the numbers that are greater than or equal to 0. Our last graph is a little different. It's a cubed root. So take a moment, plug that into your calculator, and you can get out your table. You are going to start off with the Hankin-Kelly point this time, which is negative 4, negative 3. But this time when you do an XY chart, whenever it's a cubed root, which is what we have right here, our Hankin-Kelly point is going to be our middle point. and we want to go 2 above and 2 below. So -3 and -2, -5 and -6. So plug in those numbers. Okay, made a little adjustment there at my -2, should be -1.7. We're going to plot these points. Again, I always like to plot my Hank and Kelly point first. So -4, -3. Then we plot our next points. And if you remember, this is the one that kind of looks like the letter S. There we go. Our domain, when we're dealing with cubed roots, you can plug anything in that you want. So our domain is all reals. Because we can plug anything in and it's a cubed root, we also can get anything out. So our range is all reals. Okay, next problem is a wonderful real-world application problem. So take a moment, read the problem. Give this one a try, hit pause, come back and see if we have figured it out. Okay, so for your answers, A, you should have 45.87, and B should be 120.97 as your answer. If you got those, perfectly peachy. If not, here we go. We start off with our equation. Velocity equals the square root of 2gh, and then they tell us that the velocity is 30 meters per second. So we're going to plug that value into the equation. Here we're going to do part A first. We're dealing with Earth, and Earth has a gravity of 9.81 meters per second squared. So we're going to plug into the formula. So we have 30 equals the square root of 2 times 9.81 times h. So we get 30 equals 2 times 9.81. Gives us an answer of 19.62. Oop, not a 2, 6.2. H. And because this is being square rooted, we want to do the inverse operation of that, which means square it. So now on the left-hand side, we're left with 900. On the right-hand side, we have 19.62h. We divide both sides by 19.62. And we get h equals 45.87. Make sure you label it meters. And that is your answer for how far it needs to be on Earth. Now we're going to try it for Mars. Same process. We do 30 equals the square root of 2 times, this time gravity is 3.72 times h. So we have 30 equals 2 times 3.72 gives us 7.44h, and this is still being square rooted. How do you get rid of a square root? Ah, that's right, we square both sides. 30 squared is 900 equals 7.44h. Divide both sides by 7.44. And we get h to be 120.97, and again label it meters. Yay! Okay, next one. Solve the equation. We want to check for extraneous solutions. So we're going to solve this equation. First thing we want to do is isolate the radical. We do that by adding 4 to both sides. So we're left with the cubed root of 2x plus 7 equals 5. Well, now you're going to say, well, what do we do now? It's a cubed root. However do we get rid of a cubed root? Well, this is how you do it. The inverse operation of a cubed root is cubing it. So we're going to cube both sides. On the left-hand side, we're left with 2x plus 7. On the right-hand side, 5 cubed is 125. Now we just solve the equation. We're going to subtract 7 to both sides. So 2x equals 118. Divide both sides by 2. And x equals 59. Don't circle it yet. You got to go back and check it. So we're going to take it and plug it back into the original equation and check to see if it works. So we have the cubed root of 2 times 59 plus 7, then minus 4 equals 1. So the cubed root of 2 times 59 is 118. 118 plus 7 is 125. The cubed root of 125 is 5. And then 5 minus 4 is 1. And does 1 equal 1? Yes. Yes, it does. So that means that x equals 59. Next one, try this one on your own. It's a little bit more complicated. We got a fraction in there. We actually have 2 fractions in there as a coefficient and then as an exponent. So give this one a try. Your answer you should get is 19. 19. So if you got that, absolutely marvelous. Continue on to the next question. If not, we want to get rid of this 1/2. It's being multiplied by 1/2, so we want to multiply by the reciprocal of that 1/2, which is 2 over 1. Left-hand side, they cancel out. We're left with the quantity x minus 3 to the 3/4 power equals 4 times 2, which is 8. Now we have a conundrum because we have that quantity x minus 3 is to a fractional exponent. Think back about what we did to get rid of that fractional exponent. Do you remember? Well, we're going to take it to another power of the reciprocal of that exponent. So it's to the 3/4 power. We want to take it to the 4/3 power. And what you do to one side, you got to do to the other side. So on the left-hand side, a power to a power, we multiply them. They cancel out, leaving us with just x minus 3. On the right-hand side, we have 8 to the 4/3 power. So you can plug this in your calculator, but be very careful when you do. Remember, it's 8, your caret key, and then in parentheses, 4 divided by 3. You need to make sure you do that in parentheses. If you do not, you're going to get this wrong, and that would be very, very, very bad. If you plug it in correctly, you should get out 16 as your answer here. And then all we do is add 3. And we get x equals 19. But don't circle the answer. Don't you do it. Because we have to check it. So we're going to take our answer, and we're going to plug it back into the original equation. So we have 1/2 times 19 minus 3 to the 3/4 power equals 4. And work this out to see if it checks out. We have 1/2. 19 minus 3 is 16 to the 3/4 power. 16 to the 3/4 power. Again, you can plug it in your calculator. You can think it through. The 4th root of 16 is 2, and then 2 cubed is 8. 1/2 times 8 is 4, and does 4 equal 4? Yes. Yes, it does. So x equals 19. Next problem. We have the square root of the quantity x minus 3 equals the square root of the quantity 2x minus 7. Now this one looks royally nasty and yucky because all those square roots and everything, but this is probably the simplest question we have here on the review. It's super simple once you remember the key. How do you get rid of a square root? Well, you square it. And we're going to square both sides. And because both sides have a square root and we're squaring them, they're going to completely disappear. So we are only left with what's underneath. So x minus 3 equals 2x minus 7. And now it's just solving an equation. Get all the x's to one side, regular numbers to the other. So subtract x, add 7. So we get 4 equals x. But again, don't circle your answer. We need to go back and check it. So plug it back into the original equation. Square root of 4 minus 3 equals the square root of 2 times 4 minus 7. 4 minus 3 is 1. 2 minus 4 is 8. 8 minus 7 is 1. Square root of 1 is 1. Square root of 1 is 1. Does 1 equal 1? Why, yes. Yes, it does. So our original answer of x equals 4 is the correct answer. And then the last thing is good luck on your quiz tomorrow. This is quiz 2 in in unit 6. Next week we will be having a test on all of this, and I hope to do one of these to help you on your test. So good luck, enjoy, have fun. Come in tomorrow morning if you have any more questions on any of this.